Good afternoon. Thank you for joining us for today's afternoon keynote session at CAR MBS. This afternoon's keynote session is sponsored by the Alliance for Automotive Innovation. During the session, all audience members will be muted to ensure a quality user experience for everyone participating. Please submit your questions by using the Q&A function. If you have any other questions regarding the virtual MBS experience, please feel free to ask those questions at the information desk in the virtual lobby. Please also take a moment to visit the virtual exhibits in the exhibit hall. And if you'd like to earn CEU or PDH credits for participating in CAR MBS, please visit our MBS page on our website at www.cargroup.org to access the registration link for CEUs or PDHs. Once again, thank you for joining us today. I'm pleased to welcome session moderator, CAR President and CEO, Carla Bailo.
Thank you, Katie. I'm really excited about this next keynote speaker, really talking about what the future portends in autonomous vehicles, autonomous trucking, autonomous delivery of goods, as we've all seen this huge increase during the COVID-19 pandemic. It gives me great pleasure to introduce Chris Urmson, CEO and co-founder of Aurora, the company building self-driving technology to deliver the benefits of the future of transportation safely, quickly, and broadly. Chris has been instrumental in instigating and advancing the development of self-driving vehicles and the industry for the last 15 years. Before founding Aurora, Chris helped start Google's self-driving car program and served as CTO. Prior to that, he was a faculty member of the Robotics Institute at Carnegie Mellon University, where he worked with house-sized trucks, drove robots in the desert, and was the technical director of the DARPA Urban and Grand Challenge team. He earned his PhD in robotics from Carnegie Mellon and his BSc in computer engineering from the University of Manitoba. Chris, welcome.
Thanks, Carla. Glad to be here.
Good to see you.
Should I start presenting and take it?
Please, you can take away the presentation rights, share your screen, and give us your thoughts.
It's fun. You know, you kind of get used to the dynamic of doing these things actually on stage and doing them remotely. It's just a little bit different. So here we go. To share your computer audio, please install the Zoom audio. We literally just tried this.
Yes, we did. It says, here you go. There you go. It just had a delay.
Okay, it's working. Okay, so there. It asked me for my password to install something. So fun. We'll just not do that. Anyway, so we're off to a roaring start. So good afternoon, everyone. I'm Chris. I helped found Aurora a little while ago, and I'm going to talk to you a little bit about the technology, give you an overview of self-driving cars, a little bit about Aurora, and then looking forward to a really good conversation with Carla answering questions. So I'll start with a little bit of history. This is kind of fun. You might ask yourself, this is an early concept of a self-driving car. When do you think this was from? Possibly the 50s, the 60s? Well, actually, it turns out this is a drawing from Scientific American in 1918. So the concept of self-driving cars is not a new thing. I guess it's over 100 years old. And one of the things that continues to exist is people's question about whether this technology is going to actually happen, whether it's going to be meaningful in the world. And the good news is we're in good company here. When the first iPhone came out in 2007, TechCrunch ran a piece called "We Predict the iPhone Will Bomb." It said that virtual keyboards will be about as useful tapping out emails and text messages as a rotary phone, which is fantastic. Newsweek in 1995 ran a piece about the internet, which predicted the network would never amount to anything. In 1896, a British scientific journal criticized automobiles by comparing them to horse-drawn carriages, saying they'll never succeed because a man has not the advantage or the intelligence of the horse in shaping its path. And then finally, way back in 1492, Johannes Trithomus believed that the printing press would never amount to anything because it couldn't create the beautiful codices that the monks would replicate at the time. And so over the last 600 years, and almost certainly before that, we've had reasonable doubt about the impact of technology. And so I feel like we're in good company here with self-driving technology. Of course, COVID has struck the world over the last 6 months. Prior to COVID, we expected the automotive industry to spend something like $79 billion on AVs over between 20 and 2025. We're now expecting that that is going to cut down dramatically to about $25 billion. And so we see these core industries focusing on their core capabilities, or the automotive industry focusing on their core capabilities. At Aurora, of course, we've been impacted by COVID as well. For a period of time, we pulled our vehicles off the road. Of course, our whole team is distributed. We were very fortunate in that, well, one, we built just a massive suite of virtual development tools that allowed us to continue to push the technology forward even while we were off the road. And then one of the things I joke about is, well, we're a pre-revenue company, and so it turns out that all your customers going away doesn't have an impact when you don't have large customers at this time. So we've been basically financially, at least not directly impacted by COVID. For the industry more broadly, though, what we're seeing is the potential benefits of this technology. So 26% of consumers have moved to more favorable in their perception of what logistics or what automated vehicles the impact automated vehicles could have on logistics. And, they've gone to somewhat to very favorable views on that. I think when I look at the world around us in this COVID crisis, what we're seeing is, one, there's actually a real appeal in certain circumstances to not having to interact with people in vehicles and having that extra safety cushion there. And it feels very counter to my nature, very kind of inhuman to say that, but I think many of us would feel more comfortable getting rides in vehicles today without another occupant in them. The other thing that's happened is we've accelerated the e-commerce space. Fairly dramatically through this period. People expect goods to come to them rather than going somewhere to get those goods. And to do that, to deliver on that promise, we need to automate that infrastructure. And then this is a particularly troubling quote, right? The supply chain that we rely on to be able to eat, to be able to house ourselves, to put clothes on us, is stretched very thin. The Houston Food Bank, over this period of time, over COVID, has been distributing about 25 trailer trucks worth of food on a given week. Before that, it was about 10. So that's just an incredible ramp up of demand. And this is a quote from the Greater Pittsburgh Community Food Bank, where they're just expressing the challenges of the supply chain, the idea that they may not actually be able to get food because of the constraints that we're putting in place in response to this virus. And so automated vehicles are one way to help ease that supply chain burden and make it better and simpler to get needed materials out to people who are desperately seeking them. Let me take a step back now and talk, I'm sorry. First time with this deck. And then beyond the immediate needs and the response to the pandemic and the benefits we see there, we see all of the good things that we think self-driving cars could deliver on in terms of increasing safety on the road, improving lives so that people aren't spending an hour of a day basically hating themselves and everyone around them as they're traveling to and from work. We think there's an opportunity to expand access, particularly to the 6 million Americans that don't otherwise have the ability to drive their own vehicles, and then to revitalize cities as we think about transforming the transportation ecosystem inside cities. Is an incredible opportunity there as well. So as we turn the page back to kind of how I started in this space, way back in 2003, I was down in the Atacama Desert in Chile, working with this robot, Hyperion, with a great team of folks trying to understand how you might search for life on another planet. And this robot moved at basically a very slow walk. And my PhD advisor came down and said, there's this amazing competition to build vehicles to drive across a desert at 50 miles per hour. Do you want to do it? And I thought that sounded cool. And I talked to my wife and signed up. And so for the last 17 years, this has been the type of work that I've been focused on. I had the privilege of working on that first DARPA challenge and the two that followed it, and building vehicles that could drive across a desert and then ultimately in a mock urban environment. And then in 2009, I got recruited to go to Google to help found their self-driving car team. I'd spent 7.5 years there having an opportunity to experience a number of world firsts, driving 100,000 miles on public roads, driving some beautiful, really interesting roads, allowing a blind man to get a ride in a car by himself for the first time since he'd lost his vision. And you know, that was kind of the culmination of my time at Google. Along the way, we also got the first time a self-driving car got pulled over by the police. So, you know, it was a heck of an experience. That leads us to 2016, when I had the privilege of helping found Aurora with Drew Bagnell and Sterling Anderson. Sterling is an MIT graduate. He spent time at McKinsey and then went on to Tesla to help launch Autopilot Model X. Drew Bagnell and I have known each other for 20-something years at this point. We were grad students together at Carnegie Mellon. He's built his career around developing algorithms and techniques for using machine learning to help vehicles and robots move through the world. He then helped Uber start ATG, their self-driving car program, and came to Aurora to build this with me and our amazing team. And then the mission for the company is to deliver the benefits of self-driving technology safely, quickly, and broadly. And I just point to a couple of key words in here. The first is benefits. That we're not a company that's building technology for technology's sake. We want to have a hand in how this technology comes to market and see that it actually does something good in the world, making it easier and safer for people around, making it less expensive and easier for goods to get to people who need them. And then the three adverbs here, safely, quickly, and broadly, are in that order very intentionally. We put safety first because, well, we think that A, is one of the incredible opportunities with this technology, but B, we're driving a multi-ton thing around on the world, through the world. And so you need to think first and foremost about how you could develop that technology safely and ultimately how you deploy it safely. Quickly comes from the fact that we think there's an incredible opportunity to save lives, and that 38,000 Americans die every year on our roads, and that this is a technology that can help drive that towards zero. And so the sooner we can get this technology out to market at scale, the sooner we can have an impact on that, and that's lives saved in the world. And then finally, broadly comes third, in that we want to build a technology that doesn't just help one small part of society. We think we can help with moving goods through the world. We think we can help every layer of the socioeconomic strata get through their days more safely and more effectively. What are we building? Well, we're focused on the thing that we think we can do best in the world, which is to build the driver. We don't want to build vehicles because we have an incredible respect for those companies that do that today. Some of these are companies that have been around for 100 years. You don't get to be around for 100 years by being poor at what you do. You have to be very good at it. And then we also look at whether it's logistics companies or transportation companies and look at their business and think those are incredibly complicated, and they've built up, again, decades in many cases of experience there. And so we should work in conjunction with those two types of companies to deliver to them the capability to make their products better. And that's what the Aurora Driver will do. And the Aurora Driver is a combination of software, hardware, and data services that enable a vehicle to drive safely through the world. And we've built that technology in a way that it's platform agnostic. So it can operate everything from a small electric vehicle up through a big Class 8 heavy-duty truck. And all the things in between. This is a quick video just showing the kinds of things that the Aurora Driver is capable of. So here we're stopped at a traffic light, observing a pair of pedestrians crossing in front of us, and now looking to make a left turn across traffic. And we have to first wait for our turn after asserting ourselves in the intersection, pull ourselves into the intersection, now wait for the pedestrian on the left to cross out of our path, and then now we can proceed through the intersection. This is one of the more tricky situations that we have to deal with as a human driver because, one, the flow of traffic coming down the road in front of us is not regulated, and so we have to estimate gaps in it. And then we have to deal, particularly when we're dealing in these urban and suburban environments, with not just other vehicles on the road, but also pedestrians as well, and cyclists, and all these interesting actors that operate out there. One of the neat things about the way we're developing at Aurora, one of the, I think, differentiated technologies we're building is a simulation capability and a suite of virtual development tools. And those tools have allowed us to move very rapidly, even during periods of time where we haven't been able to be on the road. And so, for example, that maneuver there, that left turn across traffic maneuver, is something where we first developed it virtually and then moved it to the road. And before we ever did a real left turn across traffic, we'd made over 2.25 million turns in simulation. And that allowed us to understand the limitations of the system and push it forward in a very safe way before engaging with everyone else. The driver itself is the core of what we build, but to actually make it useful, our partners need to be able to engage with it. And they do that through the Aurora Cloud. And this is the kind of ecosystem that will ultimately construct around the Aurora driver. And so whether it's a logistics or a transportation company, they'll be able to request from the Aurora Cloud, we need a vehicle to go from A to B. We want to get some information back from that vehicle. And then as Aurora, we're able to communicate to that vehicle and provide the software updates, the data updates, for example, for maps and perhaps the remote services, the remote operation service. And this platform agnostic approach, we've been able to prove so far. So we've integrated to, I think, 8 different vehicles at this point, everything from compact electric cars, minivans and light commercial vehicles up through, like I said, a Class 8 trucks. And those applications then really, at the end of the day, from our perspective, boil down to moving something from one place to another in the service of our customers' and partners' objectives. So today, we're putting a lot of emphasis on trucking. We think this is probably the first application that the Aurora driver sees in market. And we ultimately expect that driver, like I said, to deliver everything from people to goods through the world. But commercial logistics applications, again, particularly trucking, are where we see both the biggest unit economic opportunity and the place where the customer will be most patient. When you think about making, a vehicle has to turn across traffic, if there's a person in the back of an Uber or a taxi and they see a gap that they might have made a left turn across traffic through, well, they get a little anxious about that. And how come the driver's not going? In contrast, a roll of toilet paper in the back of a truck going from one warehouse to another, frankly, doesn't even know that it's making a left turn across traffic. And so there's an opportunity to trade some levels of performance for safety early on that allow us, we think, to bring this technology to market incrementally sooner. And additionally to that, we think as Aurora, we're pretty uniquely positioned to make this work well. One of the challenges with operating trucks on the freeway is, well, they're big and heavy and go fast. And so you have to see a long way down the road to be able to operate them safely. And when we started Aurora, we understood that technology, well, we didn't know where that technology existed. And so we spent the first couple of years of the company looking for an ability to see far enough that we could actually deliver on the promise of logistics. And last year, we acquired a company to bring that technology in-house. And over the last year, we've integrated that team and pushed the technology forward in what we call the first light LiDAR. And what's really neat about this sensor is that it can see very far. So we can see over 300 meters out. So that's about 3 football fields down the road. But not just see the thing that's there, instantaneously measure how fast that thing is moving. And so that bit of speed information allows us to assess, is that a threat coming at us? Is that something stopped in the road, or is that something moving away? It's maybe as much as a half second sooner than we would be able to do without that data. And a half second translates to an incredible margin of safety and is really significant. And so today we've taken that technology, we've built the first prototypes or additional prototypes with it, and we're integrating that into the Aurora driver. And what you're looking at on the left is what kind of traditional LiDAR data might get you. And I'll play this video one more time. You'll notice that out to about 100, 150 meters, we're seeing these little blue jelly beans, little blue boxes. Those are vehicles we can see. And that's about as far as you can see with a conventional LiDAR. In contrast, let me play this one more time. If you look at the top right on the image here, we've integrated the First Light LiDAR to our system. And you can see we're actually able to see vehicles well out past 300 meters. And again, that extra range is really material in driving safely on the road. So in closing, we're incredibly excited about the opportunities that automated vehicles will bring. The improvements in safety, the improvements in accessibility, the ability to help bolster our partners' businesses over time and create more and more both social and economic impact in the world. And so we're excited about the progress we're making. We see an incredibly bright future ahead for this, and we look forward to working with many in the audience today in realizing it. So with that, thank you very much for your time, and look forward to answering questions.
Great. Thank you so much, Chris, for sharing what Aurora is doing and a little bit of how you pivoted during COVID. I have a geeky question first, and I've driven everything. I have my class 2 license. I've driven semis. I've driven big SUVs. I've driven small cars. I've driven the Renault Zoe, the little city car, right? So you say that your driver platform is agnostic to the type of vehicle. And I know when I'm in each one of those different kinds of vehicles, I think differently. So I'm a little bit puzzled how that works. Can you put it in very simple terms that even I can understand?
Well, so first, you can drive all of those things, right?
Correct.
Right, and you think a bit differently about them, but you drive you're able to drive them. And the reason why is that, you know, so when we look at this problem, the really hard part of the problem is understanding the world around the vehicle. So where are the other actors? Where are the other vehicles, the other pedestrians, the other bicyclists, the other, you know, the debris in the road? And it doesn't really matter whether you're in a truck or whether you're in a Twizy or a Zoe, right? You still need to have that understanding of the world. Maybe you need to look a little bit further out for a truck than you do for a city car, but you still have that fundamental challenge of seeing the world around it. And then figuring out how do you move the vehicle through that world. And yes, if you're in a truck, you might get a slightly wider berth than if you're in a compact electric car. But the mechanics of figuring out how to move through the world are just the same in both cases. And so that's the really hardest part of the problem. There's definitely other work to be done, right? With a truck, notably a big Class 8 semi-trailer, right? It's articulated, it bends in the middle. And so you have to understand that the trailer doesn't go exactly the same place as the cab. You know, you have to understand that the weight shifting on a vehicle with load in it can have an impact on the dynamics and account for that. But it turns out that if you're in a minivan driving across a bridge and there's a wind load, there's a disturbance there that you have to deal with as well. And so in both cases, you have to deal with a bunch of unmodeled things. And so these parts that are maybe we find difficult, like dealing with a trailer, some of that is actually fairly straightforward geometry that's easy to encode for the vehicle. And then there's parts of it which are talking to the different vehicles, which again is work, but it's low risk engineering work. It just has to be done. And so the driver itself, right, you know, the part that understands the world is common across, and then there's this kind of 5% difference that's between each of these different applications.
Great, thanks. One thing that particularly struck me in your presentation was the fact that you're not working with any particular OEM. You don't want to build a vehicle, you want to build the driver of the vehicle. And we know that you've had some recent announcements and partnerships. Tell us about those and why they're important to Aurora.
Yeah, so we're really excited about building a platform that can support the industry broadly. So we work with a couple of different OEMs. We also work with, or are in the process of working with, folks that actually use the technology. And really, I think the best metaphor for our business is kind of the way jet engine companies are part of the aerospace industry. So if you're a major airline, you decide you want to buy an aircraft, or lease one practically. You have a conversation with primarily Airbus or Boeing, but then you also say that you want to use the Pratt & Whitney or the GE engine on it, and you have a relationship with both of those parties. And so you end up buying a Boeing 787 with a Pratt & Whitney engine on it. And so Pratt & Whitney works with Boeing to design and integrate that engine into the airframe, but then they also have a relationship with the airline. Where they're effectively buying throttle by the hour. As for Aurora, that's kind of the way we think about it, is we partner with automotive companies, partner with manufacturers, and then partner and ultimately with the user of those vehicles. And together, we're actually able to deliver something to that ultimate customer.
And tell me about some of the collaborations that you've recently announced, and again, what those are intended to bring.
Yeah, so we work with Fiat Chrysler, and we've been a bunch of work with them around the Pacifica platform. And so we've been doing some custom engineering work there. So we see that as a pathway forward for moving people through the world, and it's a great platform for us. We work with Hyundai as well. And then I think one of the collaborations may be around the acquisition of Blackmore, which we brought in, and we see as a really important strategic tool for us with creating this first light LiDAR to allow us to see down the road.
And tell us a little bit about Blackmore.
Yeah, so this is a company that we that have been working. The kind of principals there have been working on different kinds of LiDAR technology for the last 15 years or so. They're based in Bozeman, Montana, and so when I was at Google, one of the things that I helped do there was start their internal LiDAR program. And the reason why we did that there, and the reason why we're doing something similar at Aurora, is because this problem of seeing the world is very hard. And so you need to have really interesting sensor technology. You need to have really interesting software algorithms. And there's this delicate or complicated trade-off between, do we try to solve this problem in software and hardware? By having the two teams together, you're able to trade the complexity back and forward, where the hardware people say, oh, that's easy, I can just do this. And the software people can say, oh, that's great, because that would have been near impossible over here. And so at Aurora, we wanted to replicate that, but we wanted to find a technology that we thought was differentiated and kind of next generation. And so we spent a couple of years exploring what was out there, what were some of the neat, interesting ideas. And we came across this great team led by Randy and Zeb in Bozeman, Montana. And the technology is game-changing. Right, the fact that they use this capability called FMCW, frequency modulated continuous wave. And what that means is, unlike a conventional LiDAR, which basically shoots out a super bright spike of light, that spike goes out into the world, bounces off, and comes back. You can kind of think of it like a sonar ping from a submarine movie, except it's light. And then comes back, and you measure out how long it took for that thing to go out and back, and that gives you a distance because light moves at a constant speed. Well, the way FMCW works is it's just constantly emitting this wave, and you look at the phase difference, so kind of the point that you're on the wave, when it went out, when it comes back, and that tells you how far away the thing is.
Okay.
What's neat about this is first, the pulse thing, the sonar-like thing, well, you have to be really bright, because there's bright stuff out there, like other vehicles' headlights and the sun. And so if you're just looking for a bright spike that comes back, you can get occluded by that. And then at some point you can't get any brighter because you're so bright that you damage people's eyes. In contrast, this FMCW technology is about 20 times more efficient in the way it measures the world. So you can use 20 times less light to see just as far. So that means you can use a bit more light and see dramatically farther because of it. And the other cool thing is, because of the way this waveform, you can actually measure the shift in frequency. So if you've listened to a police car go by and you know how the siren changes tone as it goes by, that's the Doppler effect. Well, you can actually get the same thing happening with light, it turns out. And so we can measure that Doppler shift in the sensor, and that's how we can measure the speed of something that the light's bouncing off out in the distance. And that instantaneous measure of velocity means that we can react to things more quickly, which means we can be safer, which is really exciting.
Yes, indeed. I'm getting totally geeked out now. I could keep asking more and more questions. Bozeman is a great place. Was it from the university there, or?
So it's a company that had been around. It spun out of a different company.
Okay.
Yeah, but it's a deep connection with the university there. Yeah. And Bozeman is beautiful and fantastic.
Yes, it is. I visited it for the first time last year skiing. So really enjoyed it. Now back to what you're doing.
Sure.
The DARPA Grand Challenge was really groundbreaking, I think, with the different universities that participated, the learnings that occurred there. Now we're doing this Indy Grand Challenge, right, with race cars. You have any thoughts about that and what that's going to teach us, or what impact that may have on the racing world? I know it's an off-the-wall question, but I think someone threw it in the chat room. So
I think it should be a lot of fun, right? I think that it's an idea actually that I explored 15 years ago and thought about and didn't really have traction at the time. And it seems like a lot of fun. I'm not, like, I think it'll be a really interesting learning tool.
Mm-hmm.
It's not clear how transferable that experience is to the core of the problems that we have on road.
Mm-hmm.
But I think it'll be a really great educational opportunity for folks.
Yeah, absolutely. I can't wait to see it. I remember I was at a session. It was a session with Bosch in Chicago, and they had Will Power from Penske's racing team.
Yeah.
And they were asking him if they would ever have autonomous race cars. And his answer was, well, no, because the driver has to do this, 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 and this. And then the next question was, how much technology is in the car? You know, how many messages are you getting and how much is being done for you? And it was really quite interesting to hear really how much was being done, how many messages they get. And they're almost, even though of course they're excellent drivers, they're almost a robot as well with the amount of data that's coming in. So it was, interesting.
I think if by robot you mean they process an immense amount of information.
Correct.
Right? I think that's incredible. Yeah. So I'm a bit of a F1 fan, and it's just it's amazing to see. I don't know if anyone caught this last weekend, but the Mercedes Lewis Hamilton's tire blew out actually three of them blew out. Hamilton's tire blew out, and he managed to drive 150 miles per hour on a racetrack with 3 wheels.
Isn't that amazing?
It's amazing.
Their skill is amazing.
Yeah.
So let's go back to self-driving technology for a little bit.
Sure.
You know, we keep hearing it's coming.
Yep.
So, the $1 million question is when, but I think more compelling is why is it taking so long? And then a subsequent question is level 3 ever going to be possible where the car can drive itself, but we expect people to stay vigilant and able to take control again?
Yeah, so let me go maybe answer them in reverse order. So I think that I think level 3 is really challenging. This is something I've been saying for a while, that the kind of, for those of you who aren't familiar, so level 3, so SAE came up with 5 levels of autonomy. Level 0 is basically your classic car. Level 5 is can drive all places, everywhere. L2 means that you have some level of driver assistance, and it can do both steering or braking, steering and braking, or steering longitudinal control, but you have to be monitoring it. And L3 is this point where the car is going to drive itself, but you don't have to pay attention until it tells you to, and then you have to wake up and within some time window take over it. I just don't think it's viable, because I think fundamentally, if someone is checked out for the last hour, and then you don't really know what they're doing, whether they're watching a movie or engrossed in a book or asleep, for them to regain situational awareness in a handful of seconds and take over, it doesn't seem viable. And so in practice, I think any L3 system has to become an L4 system, which means a system that can drive itself the whole time without driver support, but is constrained in the environments that it would operate in. Because if you think about the bad events that happen on the road, they don't unfold over 30 seconds. They unfold over fractions of a second.
Mm-hmm.
And so by the time that the scary thing is happening, you need to be mitigating that immediately. And so that really means to me that you can't get a real L3 system. What you may do is take a system that can bring the vehicle to a safe stop, maybe doesn't get you to the end of the mission, and so pulls to the side of the road or something, and then you drive it, and brand it as an L3 system. But it in kind of the pure way that SAE talks about it, doesn't make sense to me. So why is it taking so long? It's really hard, right? It turns out that that most people don't fundamentally understand how hard it is to understand this very widely varying world and do that with a high degree of reliability and robustness. and the dimensionality. Like we have some constraints given that we're operating on roads, and that narrows the space, and that's what makes it plausible in my mind that we'll get there. Why I have confidence we'll get there, but it's just a very difficult problem. And one of the things if you look at any other technology, you know, we're taking self-driving here, but whether it's battery electric or whether it is other ADAS systems, these take decades to develop. And with self-driving, we've been in the public eye for much of the development time. And we've kind of captured the imagination because it is so compelling, it is so impactful. And so I think that there's a combination of it being really hard. We're exposed to it as the public much earlier in the development cycle than we would be with normal technology development programs. And then it captured the imagination in a way that it brought a lot of people into the game, many of whom didn't really understand how hard this problem was. And so I think that's part of the dynamic here. And that's where I'm so excited about the crew we have together at Aurora. We have people who have deep experience. We've been able to set ourselves up with investors and with partners and with employees who get that this is a long game, not, you know, an overnight, you know, flash in the pan. And so when's it going to happen? Well, it really depends. Like the question is really more of how is it going to happen? Because, you know, there's been self-driving cars at Heathrow Airport for the last decade, and they drove from the terminal to a parking lot, you know, between fences. And so that, you know, there's been in Dubai, there's been the system under Masdar City that drives around, again, separated from people. There's Waymo today has vehicles in Phoenix, a handful of them where you can get in without a driver. And so now it's a question of, it's really how do we expand the deployment? How do we scale it up over time? And that's going to be happening, you know, over the next 30 years, 50 years, right, as we get to ubiquity.
And you mentioned in your presentation about simulation and, you know, the importance of simulation and the work that you're doing there. How much, you know, when you're looking at machine learning or artificial intelligence, how much is simulated and how much do you go out on the real world? And do you expect that dynamic to gradually shift to more and more simulation? And the reason I'm asking is, you know, being in the automotive industry as long as I was, when we first started testing vehicles, everything was done test by test on the proving ground. And now it's 85% is done by simulation. You release the parts and you just verify on the proving ground or in the crash lab.
And that's part of what we've been doing and thinking about at Aurora, right? Is Aurora was kind of founded on this idea that we could be the next generation company in this space and take that experience that many of us have of doing this the hard way and earning, you know, our scars. And then how do we do it kind of quote unquote right now? And that's where one of the places where at Aurora we've invested heavily is simulation, not just simulating and a variety of other virtual development tools, but not just simulating the dynamics of the vehicle, but also simulating the sensor feedback. And so we do think it's important to be out on the road, just like the automotive guys, you know, do testing on road. But we think there's an immense value in simulation, and we use that as part of our test and development cycle. And again, it's how we were able to be so efficient and effective during the shutdown.
Sure, sure. I have a question about public perception and customer acceptance and how that correlates to safety, which is core to everything that you're talking about. We saw the hype, you know, in 2014, 15, autonomous is coming, everyone was excited about it. Then we saw, you know, certain incidents that have happened with certain manufacturers that I'm not going to name, but then people started saying, oh, I don't know if I'm going to ever trust an autonomous vehicle. How can we regain that with an emphasis on safety as Aurora has an emphasis?
Yeah, and this is one of the things where early in the company, we helped found PAVE, which is this group that's about building and educating folks around the technology. I guess I'd start though by kind of questioning the premise of the question, right? In that I think that, the statistics I've seen are something like 30 or 40% of Americans, but it's generally phrased as 60 to 70% of Americans are anxious about self-driving cars, right? Or wouldn't want to ride in a self-driving.
Right. But I think you have to look at the demographic, and probably you have to wonder how those questions were phased or
You do?
phrased, because the survey results are only as good as the question that was asked. But go ahead.
But even, let's just take it at face value,
Yeah.
right?
Okay.
That means that 30 to 40% of Americans want to ride in a self-driving car.
Yeah.
Right. And so that's 300 million Americans times 30%. That's 90 million people are excited to ride in a technology that doesn't exist yet. And so I guess I don't worry about this problem, because I've seen, I think it's important that we do our part in education. It's important that we help regulators, policymakers understand the technology so we can prepare as a society for it, and kind of harden it and bring it forward in a way that delivers benefits. But in terms of people accepting it, right, if you'd asked me, who's a tech savvy, excited person, do I really want an iPhone or need one? The answer was no. And now today, it's like it's glued to me, right? And what I've seen over the years is we get people that have anxiety or are questioning whether they care or want to use this technology, and they experience it, and within minutes the bit flips. Like, oh, I actually, you're right, I do kind of hate just the boring part of commuting. I might enjoy driving when I get to be somewhere beautiful and with low traffic, but the 101 sucks, right? The 405 sucks. And so if I could be if I could be having a nap, if I could be reading a book, if I could be watching a movie, if I'm a farmer and I can now get my dairy goods farther out and serve a bigger market, if I can now get to work without having to lean on someone else to drive me because I can't see and drive myself. If I'm elderly and have now been, shouldn't be driving, feel guilty about driving, but now can get to go visit my children or just go to the store to pick up my prescription, and have that freedom and social interaction, right? It's incredibly empowering. And so I think the burden is on us as a technology, as those pushing this forward to build, high integrity companies and quality technology, and then deliver a product in the market, and then I'm convinced that people are going to be excited for it.
Yeah, I really couldn't agree with you more. When in my age group, I'm a boomer, there's a silver tsunami coming, and most of us are going to outlive our driver's license by 10 years. But I imagine we're still going to want to go see our friends, if we can see people by then, see our friends and go grocery shopping and do those things that give you that normalcy, that makes you feel alive. Yeah, so, I truly agree. So my next question was about, how can your platform really help lives of citizens and not just the elderly, because that's clearly one segment, but we have a lot of underserved communities that can't get access to fresh food. The farmers can't get their fresh food to these places, can't get access to education, can't get access to jobs. Yeah. How can this technology help that?
Well, I think it can provide it, right? That it can extend the reach because we can now, we can move produce farther more quickly, so it can get to broader markets. I think ultimately this technology has the promise to reshape public transportation, that we can provide smaller multi-occupancy vehicles that are part of the public transit network, and allow people either to get to branch lines or just to get point to point in a way that's economically viable, right? And we've all heard the challenges of folks, particularly often folks that are lower in the economic strata, that they're taking 3 different buses and commuting for 3 hours in the morning to get to their job. Imagine, and the reason why is because that route is kind of off nominal. Whereas if we can reduce the cost of operating that service, then we can provide those people that access, right? And this is something, when I look at the the opportunity over the next decades, that leveling of the socioeconomic landscape is really exciting.
I think that's truly, truly important. I've heard stories, same as you know, minimum wage folks spending 3 hours on a route that maybe is less than 10 miles because, you know, that's just the way the route goes, and with changes and time delays. And we really need to find a more efficient way to be able to enable everybody to be on the same, let's say, same level playing field. I have a question about autonomous trucking versus vehicles, passenger vehicles, be it in a urban, exurban, suburban setting. I've often said it's going to be easier to get those big semis out in the open road. Let's take Montana, for example, you know, driving autonomously than others. And then other people have said, no, 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 that's not true. I'd like your view.
I think the challenges are different, right? So if you're, and sorry, the question is it easier to drive on the freeway or than an urban environment, or?
Well, that, and specifically big trucks versus passenger carrying vehicles.
Yeah.
Cargo carrying vehicles versus passenger.
Yeah, and so cargo carrying vehicles have the advantage that the thing that's on board doesn't get anxious, right? That they're not going to be demanding that you make that left turn, or, you know, hey, you're going down 5th and we should be going down 4th at 3 o'clock, right? Like, you know, so there's just a human-centric, customer-centric part there that's a little different, that may allow us to, like I said earlier, to trade some performance for safety early on, right? I think that's really interesting. I think that it's like, frankly, it's more difficult to drive a big thing in a constrained environment than it is to drive a small thing in a constrained environment, right? Anyone who's, you know, moved from driving a Prius to a Camaro through a city, right? It's just a different experience. And so that's, you know, it's incrementally easier or harder depending on the size of the vehicle. I think urban environments, you end up with a more dynamic, you know, there's more actors, there's more close interactions. Freeway dynamic, things are moving faster, you have to see further. And so the challenges are a bit different. But honestly, one of the myths that kind of was being told over the last few years was that, oh, we're going to go do trucking because it's dramatically easier than urban driving. And I think that's just not the case. I think most of the time, freeway driving is easier, right? But the problem is we don't care about most of the time. If you're going to take the driver out of the vehicle, it needs to be pretty much all of the time it works well. And you don't get to discount, oh yeah, that was only hard because, you know, this, that, and the other happened in the world, right? You have to be able to deal with those, and at speed, and given the extra inertia of those vehicles, those situations are challenging. And that's why we, as a company, getting those lessons in urban driving early and all the work that we've been doing there, we see that benefiting directly to what we're doing with trucks. And we think that sensor capability will be an incredible enabler as well.
Sure. So I have one last question for you, and it's maybe an odd one. In the automotive industry, we're having one heck of a time recruiting good talent. It's one of the biggest rallying cries that we have throughout the industry right now. And so I have to ask you, you know, in your company, you've got some amazing talent. Some you've known for years, but I'm sure some is fresh talent. How are you recruiting that talent, and how are you keeping that talent? Yeah,
so I think that it's hard, right? You have to work at it, and everyone does. I think when I think about attracting great people, it's a combination of a few things. So the first is there needs to be a vision that they find compelling, right? The great people want to do something important. And so having a vision for what we're doing, why we're doing it, be able to tie the work that we're doing to that is really meaningful to people. The second is you need to have a culture and kind of a management structure that enables people to excel and creates an environment where they can do their best work, because that word travels, right? If you get a reputation for being a place where good people come together, where they work well together, where they have you know, the opportunity to do things that matter, that gets out, and that makes it even better to recruit folks. Yeah, I think that's really at the heart of it. And then you need to pay them in a way that's not embarrassing.
Sure,
Right?
sure.
That most people, the biggest impacts on where and whether they want to stay there is the managers that they report to, and does that work well? Most people don't leave companies; they leave managers, right? And then they need to have a vision, and they need to be able to do interesting things day to day. And my philosophy on that has been, you need the vision, because it doesn't matter how good the job is, you have crappy days, and so you need to have that purpose. But at the same time, if you just have vision and you end up, your kind of work experience sucks day to day, then, you're going to move on, because,
Exactly.
it's just, so you need to balance the two.
Well, it's really been a pleasure chatting with you this afternoon. I appreciate your time, appreciate learning more about Aurora. You have any closing thoughts you want to give to those in our audience that are automotive geeks?
Well, first, thank you very much for the invitation, the opportunity to be here, and thanks to everyone who tuned in to hear us talk. Tuned in, wow, that's become an anachronism, hasn't it?
It has, indeed.
Yeah, it didn't occur to me until afterwards, but I guess the thoughts, I think it's an incredible time to be working in transportation, right? And when we're seeing, I understand there's been a hype wave around this, but the underlying momentum is real, and it's there. And this, whether it's the combination of electrification and environmental impact and what that's having with vehicles, connectivity, whether that is just kind of the kind of the bits getting to the car, but also the applications around logistics and transportation that enables on top of the vehicle platform, and then automation, and what that's going to mean for re-enabling society, and kind of, the next step of the Henry Ford's vision of, providing transportation for everyone is what we're in the midst of building. And so it's just an incredible opportunity, and, at Aurora, we're thrilled to be part of it, and look forward to working with folks to make it a reality.
What a super way to close. I know I've been in the industry for a little over 40 years, and I keep telling everybody it's never been more fun and more interesting. It's a great time to be in the mobility space. Thank you again, Chris, and thank you very much to the audience for joining us. Actually, this concludes MBS 2020. So I hope you all have enjoyed it, and have a great evening or rest of your day wherever you are. Thanks so much. Bye now.